I should tell you, Evan was a little vague about the talk. He said, the title, Ches's Computer Security Adventures. Okay, I can do that. And I got here today and he said, this is about old computing, right? And I sort of felt sort of like a guy who'd prepared a talk on 6 transistor radios and then told, oh, you are covering electromagnetism in the 1700s, right? Because when you think about it, computer and network security, with an exception I'll mention in a moment, really started around the 1960s. That really is the old days. Before that, there were computers, and they were secured, and we're mostly talking Marine Guards, hunks of thermite, and the Official Secrets Act. And you can decide for yourself whether you want to talk about Bletchley or fire control computers, and some of the other early computing efforts. Most of the computing efforts, though, were big computers stuck in machine rooms. And it is my contention that right now is still the early days of computer security. We are basically just barely past the Model T stage. And I actually have a whole talk that discusses that and says, there's a reason it's so bad right now. We're new at this. Don't let Moore's Law confuse you. We're still very, very new at this. And therefore, I consider the vintage of network security to be still going on. Now, if you don't like this, there are 6 SJ7 GTs over in the building over there. You can go find your tubes, and it's fascinating stuff. But I think maybe I can show you a little bit about how some of this stuff has evolved. And I took this, I took Evan's query a little bit a lot autobiographical. I hope you don't mind, because I've been in the middle of it for a long time. And it does start in legacy times. I'm a science guy. I was born in the early 1950s, which means when Sputnik went up, I was one of the people who got caught up in all the science education that happened after it. I was a science guy by 3rd grade. By 6th grade, I was very proud at the time to say that my report card said I probably knew more science than the science teacher. Now, looking back on that, I consider that a huge damning indictment. Is this a ground loop? It's a damning indictment. This was a huge indictment on our school system because 6th graders should not be learning science on their own. So in the mid-60s, I was going to be a chemist. And that is for the usual reasons that 12-year-olds want to become chemists, because you can play with cool stuff and blow things up. And I survived it. All my fingers are intact. My vision is not perfect, but it's not because I did poor chemistry. And I went to Lawrenceville. And in 1968, I walked into a math room, and there was a teletype in the corner, a Model 33 teletype, one of the old steam-driven ones. And I said, computers, they're the wave of the future. I should learn a little bit about them. This was about one of 3 career decisions that basically changed my whole life. And we'll get back to that. I went to Lehigh. Lehigh had a mainframe, something I'd never worked with before. These were $1 million computers run by acolytes, people who got to go in and actually touch the machine. Every day they shut it down for an hour and a half for diagnostics. And they'd run margins, crank the speed up and down and the voltage up and down and see what broke. And fix it. And they do that at 6 o'clock every morning. This is how computers worked. And of course, if the power went out, it would drop off and immediately get several errors in it that had to have this. So it took a flicker of the lights meant, oh God, we've got 90 minutes of the computer down, as they come in and slowly bring things back up. Of course, I quickly became an acolyte. These machines came with their own operating system, and these were very primitive operating systems in many ways. For example, the prototype time-sharing systems didn't have something as simple as type ahead. You had to wait till the computer was damn ready before you typed something. It would either ignore it, or get confused, or stop its output. There was even a terminal called a 2741, where if you hit a key and it wasn't ready, the key just went sort of chunk and stuck down until it was ready. You had to hit the attention button, and about a second later it would say, yes sir, you type in your line, enter, and then the keyboard is locked again. This is truly half duplex. So there were a lot of things that were very primitive, and I look forward to stuff that's now in all the kernels so you can do this. And yes, we hacked the machine. Obviously, these computers were not connected to each other. There was no networking, but there were CPU second limits. This computer had one, excuse me, was a 1 MIP machine, and you paid by the CPU second. And an account for an engineering student might allow 8 CPU seconds for one job, and then boom, CPU time limit, you're gone. So this takes care of loops and so on. But it means if you actually had 16 seconds worth of work you wanted to do, you were in trouble. And what we would do is try to figure out ways past the operating system to get a longer CPU time. And we found some. Of course, what happened in those days is if you hacked a machine, you either got hauled in front of the dean and maybe kicked out, or you got hired. And I got hired. And the first thing they give you is the system administrator's account that has $78,000 of fake money in it and no CPU time limits. So this worked out really well. About 10 years ago, I generated a movie. I started a movie up on a Friday night, and an hour and a half later, realized that the MPEG encoding was wrong. Oh, this is going to be a long haul. And I aborted it, Control-C, and started it up with a different parameter. And then it occurred to me, I just wasted 90 minutes of CPU time. How does that compare to the CPU time back at Lehigh? And it turns out it was more CPU time than was available to the entire university for my entire undergraduate career. Moore's Law is pretty startling when you've lived through it. And in fact, there have been 6 times in my life where I've sat down to a new computer, typed in a command I knew well, and the prompt came back so quickly I said, that couldn't have worked, it was too fast. Literally, that has happened to me 6 times in my life. And of course, you go look around and know the answer was done. This was Moore's Law that really kicked in, speeding up CPUs at amazing rates. Unfortunately, that stopped around the early 2000s. You know, where is my Octium 1 terahertz Intel computer? Well, that stopped. We now have lots of computers, and it's like taming butterflies. So you may notice that I have about 114 slides. And I've been talking I've used 12 minutes of my 50-minute time slot. So these next slides must go by pretty quickly, and they do. So I was a system programmer. System programmer was sort of a kernel hacker because we had the source code, an IT guy, a consultant because users didn't know what core dumps looked like and how to read them, and that's how you debugged your Fortran program. And communications, you did modem stuff, RS-232 stuff, that kind of thing. You know, and you got to use this computer as a personal computer. Occasionally, all you had to do was show up at midnight, because the midnight to 6 a.m. shift was often used for system maintenance, compiling new stuff, and trying new systems, and so on. I was also doing stuff at the time, like these new microprocessors were coming out. And Don Lancaster had written a nice book on how to wire together these 7400 TTL circuits, and I'd played with them, built a little terminal. And I ended up at the American Newspaper Publishers Association Research Institute doing software for a hardware-based spelling checker, truly a device that was after its time. And the guy who did the hardware left. And I stepped in with my 7400 skills and the 6809 skills, and I actually got it working. My circuit is part of the patent, so I consider myself to be a double E. That's one of my flags. So I worked for a number of years at various places, at the Navy base down in Warminster, and for a consulting company where I was the hired hand at a bunch of different universities. And of course, universities are a great place to practice security because the students are the enemy, just like I was. And yes, you even hire them. Some of them from Temple are still friends of mine 40 years later. And the other thing I did while I was working at NJIT, there was this new network coming along. Now, there'd been local area networks, and this new network, this ARPANET, seemed interesting, and I thought, I should learn something about this because this looks like it's the wave of the future. Ding, there's two. The other thing I did was I went to conferences. And I went where the gods of the field were. I wanted to go hear Dennis Ritchie give a talk. I wanted to hang out with him afterwards and hear what he thought was interesting and useful. I had read the Bell System Technical Journal in 1984, and I loved the less is more philosophy that was coming out of Bell Labs and the Unix folks. Keep it simple, build it together like this. And I met various people. I still give this as advice to students. When you go out into the university, when you go out from the university and you start a job, tell them they have to pay for one conference a year, conference of your choice in your field, and they're going to pay for it without any complaint, and you're going to go and stay in the conference hotel and hang out with the leaders in your field to find out what's really going on. I did that, and in 1987, I said, I wonder if I could work at Bell Labs. Could I do this? I'm an IT guy. I could go be janitor for Dennis Ritchie. How cool would that be? And I applied, and the interview for the day involved 8 people, most of whom many of you have heard of: Brian Kernahan, Rob Pike, Ken Thompson, Dennis Ritchie, and a couple others, my future bosses. And I decided, even if at the end of the day they decided I was a jerk and they never wanted to see me again, it was a pretty remarkable day. And it turns out they hired me. And I started at the end of 1987. Now, I should tell you that I had had a policy ever since college, and I had told my bosses this, that I was going to spend about 20% of my time on my own projects. Does this sound familiar? This is what Google's policy is. And I started that for myself around 1975, 76. And I found that these extra projects, I couldn't always just focus on one. These extra projects would usually fold into the mainstream and be useful. And so it was pretty cool. But I got to Bell Labs and found that no, it's not 20%, it's 100%. I was working there for 3 weeks, and I said, well, I volunteered to work as postmaster, which is kind of like volunteering to be proctologist. It's a thankless job because if you get it right, nobody notices. And if you don't, they're really pissed off with you. And I went up to the postmaster, Dave Prezzato, and I said, this email seems like a wave of the future. I want to learn something about it. I'll be postmaster. He said, okay, you got it. I also took over a prototype firewall he'd put up about a year before and started running it. And I also went back to my boss after a month and said, I'm doing a bunch of stuff. Is this why you hired me? Am I doing what you hoped I would do? Because they were really not specific, because you're supposed to make your own way. And he basically said, we can get any 10 people we want off the street to do work at the labs, but getting someone who knows what to do, that's different. So I said, cool. They liked what I'm doing. And about a year later, the Morris worm came out, and our firewall stopped it. In fact, I woke up the morning the Morris worm hit the internet, and a friend of ours had called the house and said, there's something bad on the internet. You might want to check it out. And I went into work, and there was Peter Weinberger on the phone calling various places and saying, did you get the worm? We didn't. Ha, 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 ha. And of course, it was my firewall that was keeping it out. I had modified Dave's firewall. I had started doing stuff. For example, about 5 months beforehand, I had been just sort of wandering through. It was the end of the day. I didn't feel like doing much. I'll just sort of wander around this machine and see what's in there. And I found some services in Etsy, inetd.conf, that I didn't understand. Things like FingerD. And they were running as root. These are dangerous. I said, I don't know what this is. I'm shutting it off. Because I'm sort of lazy. It's the end of the day. I'm not looking them up. And I shut off a bunch of them. One of those was how the Morris worm was one of the 3 ways that the Morris worm spread. So I kept the worm out of Bell Labs by dumb luck. And I didn't like that. And in fact, that has sort of affected my approach to security ever since. I don't want dumb luck and pig ignorance to be it. It's much better to say, you broke into the IIS server, No problem. I'm not running the IIS server. Best block is no be there, as Mr. Miyagi says in The Karate Kid. If you're not part of the game, you can't lose it. So that was the Morris Worm and the firewall. I still was not strictly delighted with the firewall. It had some weaknesses. And so I redesigned it and made it 2 layers. I'll go through that. I met this fellow named Steve Bellevin, who taught me TCPIP, and we started doing work with this stuff because we got time. We can do what you want. And started looking. We built the first packet telescope, which basically meant we said, hey world, network 12 is here. Network 12 is AT&T's internet address. We got it back in 1998 by asking for it. We said, can we have this Class A address? Class A address probably has a market value of $1 billion now, something like that. We said, we need it. And they said, oh, you're a big company, you get one. Sure, we're giving them out to every big company. And, you know, and so Net 12 came to us, and we couldn't use it. It was too big. So we had this big useless address, and I said, let's gather all the traffic that comes to this big unused network and watch it and see what it is. It's a packet telescope. And Steve Bellevin put up some monitoring and so on, and we got about 25 megabytes a day of random packets, which basically were the death screams of various machines around the internet that were shouting packets at that network. We set up a read-only network link. How do you do that? Back in those days, Ethernet was a thick thing. You'd plug it in, and Steve snipped the transmit wire. That's the kind of security you want. Open, the wire is not connected. You like it to be easy to audit your security, and a snipped wire is great. It turns out that machine still communicated with the internet because the packets would come in over that and go out all the way through AT&T and out through some other exit back to where it came from. Which is a really... Huh?
That's routing.
It's routing. It's routing. We had to do stuff about that. But, you know, sometimes a cut wire isn't good enough, and we'll get back to that. I also played with PC viruses. I had a PC, an AT&T 386 with all sorts of warnings on it, and I put viruses in it. Back then, viruses were things like falling tears and so on, and they would do stuff like destroy your hard drive or give a political comment on a particular date, that sort of stuff. Now, of course, I don't have a PhD, and I'm sitting in this room with the gods of Unix. Dave Prezzato, Ken Thompson was sitting over there doing what he does. Rob Pike would come in, had lunch with Brian Kernahan and Dennis Ritchie. I was in Nirvana, and I was running their email. And I had just redesigned this firewall. And I said, you know, all these guys are writing papers. I could write a paper about this firewall. And I wrote up a 6-page paper, and I gave it to my boss. And he looked at it and said, this is a good paper. Cool. So I printed it out and submitted it to Usenix. And the basics of the paper was, here was our original firewall, and it was dangerous. Well, firewalls mostly are diodes, right? There's a good side and a bad side. And so therefore, my firewall had 2 firewalls. Okay, harder to get through. And they were mostly different. So that was basically the idea, the design of a secure internet gateway, to which one referee said, well, why don't you just do this then? These were not Zener diodes, by the way. And it turns out this paper this was building a really rock solid, highly, almost provably secure firewall, which we don't use these days. Because there's so much other stuff that's screwed up around there, it doesn't need to be this secure. But the paper did make 2 contributions that are hanging around now. I didn't think of either of them at the time. One is that I said that the internal machines were untested, a crunchy shell around a soft, chewy center. I have heard that in dozens of talks, usually unattributed. That was me, folks. I got the paper to prove it. They still have it. This is a corporate network with a perimeter defense, and inside it's a mess. Though nowadays I say a liquid center. The other was I had software that could relay connections from the inside to the outside without the user knowing about it. And the program that did this was originally called GateD, but there already was a GateD, so I had to change it. I said, I need a name for this service. And I sat there and I said, well, I'm going to call it a proxy. And about 10 years ago, I realized that this is the first use of proxy in its current use. Now, the word goes back to the 1300s. But I said, ooh, I coined the word. I should get in touch with the OED. Anyway, that's where it came from. And so there you go. It sort of surprised me. Okay, cool. Being there early and with free time lets you play with this stuff and maybe make a difference. Some of this... I've had marketing people call me the father of the firewall. I've told my son and daughter that they're brother and sister of the firewall. In fact, I had not built the original firewall. There are about 8 people involved in various firewall technologies. I was one of them, but I'm certainly not the inventor of the firewall, but I did invent bits of it. So you can decide for yourself how much that counts. In fact, the real contribution came a little later. So once I have a good solid firewall behind me, what can I do? I can play Cliff Stahl's game. I can go play with hackers because they're not getting through this firewall. This thing is rock solid, and I know it. And I've got alarms and stuff on it. So I set up this nice little honeypot. We didn't call it a honeypot, but it was a honeypot. Not the first one, but maybe one of the most fun ones. It was manually operated. Which is not the way you should do this. And when Dutch hackers started attacking a whole bunch of parts of the network, including Stanford and so on, I said, I want him to come attack our network and then attack other people from us, because I had set up a way to watch all their keystrokes. Now, there were countless thousands of machines that they could attack from and launder their connections. I wanted them to pick a machine that was instrumented so we could see where he went, find out what his techniques are, and warn the people who were attacked. Seems like a good idea. And I wrote a paper, An Evening with Burford, in which a hacker is lured, endured, and studied. And it was a manual honeypot. We had a variety of honeypots on the outside. For example, the anonymous FTP directory has a password file in it. And some people put their real password file in there, which of course can be obtained and cracked. And I had one too, except that the passwords in here, if you crack them, come out to be, why are you wasting your time? I even got a call from AT&T Corporate Security a couple of years later. The bad guys have your root password. Oh, that's not fun. What is it? It's why. Okay. And they would attack various daemons that looked like they had the bugs found in SendMail. Of course, all we did was just collect the attacks and not let them in. So this was my second paper. And I'm not going to talk about Burford. That's a whole other talk. You can go read it if you want to hear about it. But basically, he was attacking my machine and through my machine, and I didn't have any automated responses. So I had to manually reconfigure the machine as he attacked me. I had to convince him that the machine was slow and that the system administrator was confused. And by the end of the evening, he got frustrated and gave me this command. By the way, this attack all occurred during the air bombing of the first Gulf War. So one wondered, is this related? Turns out it wasn't. I have some slides here I'm not going to go through on how the gateway was set up. There's a paper and a book you can read that talks about how all these things went through here, and it's technology. You don't run DataKit anymore. There are a few people here who probably know what DataKit is, talk about legacy systems, but it's long gone. What I did do was analyze what hours he attacked, because you might be able to figure out where he lives. And it turned out this actually gave a fair indication of Europe. And I've since done that. This is, my iPhone was stolen about 6 years ago. You don't want to steal my iPhone. I have the time and the skills and the connections. The fellow who stole my iPhone has a record now. But you could tell when he was using it. This is something I used to find out when he used the iPhone, and I could tell when he broke for work, he had a part-time job, when he slept, and so on, which helped us find the radios in it when we drove by. So this was the early 1990s, and I kept working with Steve Bellevin. And around 1993, I said, you know, we could put these 5, 8, 13 papers together and make a nice book out of it. And Steve says, you know, there's a publisher who's been bugging me for 10 years to write a book. Well, let's talk to him. And we talked to him, and he said, this is a great idea, firewall book, but you can't staple papers together. Oh, you have to write it. It's sort of like someone saying, you have 14 English papers due. And I was as excited about English papers as many people in my type were back in junior high and so on. But Steve and I got to work on it. And in May 1994, we're about to have our 20th birthday party for this in a month or so. Firewalls and Internet Security came out. It was the first full Firewalls book available, and it sold over 100,000 copies. It was at exactly the right time. In fact, it was so popular, there were people who were saying, I can't wait for it to come out in May. This is in February. Please send me the draft so I can get to work on it. And we said, okay, but you have to give us comments in 3 days on the whole thing. So this actually had several reviewers read through the whole book before it came out. This ended up being a 320-page business card. This is what made me famous. It was a pain in the neck, but it was a lot of fun. And I started getting invited to places as a security expert because I wrote this book. By the way, this is the second edition. We came out in 2003 with another one with Avi Rubin helping out. So in 1996, a couple of things happened of security interest. One was the Highlands Forum, which I'll get to in a moment. And the second was we saw really the first denial of service attack. So the Highlands Forum was run by the Navy, still is. And what they do is they get people there to talk about topics. And the particular topic they were doing, this was in Annapolis, as a matter of fact. Fred Cohen was there. I got to meet him. Jerry Post is works for the CIA and is basically a profiler. The president talks to Jerry Post and says, if I make an agreement with this dictator, is he likely to keep it? Well, says Jerry, let me look at his desk. And he looks at his desk and he says, okay, this kind of personality is going to do that. Jerry Post made a comment about Fred Cohen and I. Fred Cohen did the first PC virus, by the way, back in 1983. He said, we have a profile for people like you. You have sublimated criminal tendencies. And I guess he's probably right. So what we did was a day after scenario. What we're doing is, it was a little game where you pretend it's 10 years in the future. And there are a whole bunch of buzzword-compliant attacks because they didn't know what sort of attacks would occur in 2006. And then you meet and you discuss the nature of the attack, and then you advise the president. And then the game continues. Okay, it's a week later. Much more nastier things are happening. You discuss it. You advise the president. And at the end of this, I said, well, what you really would want to know in the circumstance is you'd want to know where this came from in the network. Where you'd want to map. You'd want to know where things were connected. Who should do that? And basically the answer was, we can't do that, but you could. And so I started thinking about mapping the internet. And we'll get to that in a moment. The other was the first big denial of service attack that came against Panics.com in New York, and later several other sites like the New York Times. And what happened was, it was a SYN packet attack. It's a kind of attack, it's the only attack we did not put in our book. So the question is, when you write a book about security, do you tell about all the bad things? Because you're teaching the bad guys. And we were, well, you know, the bad guys have a lot of time to learn this. The good guys are counting on the book to teach them what's going to happen. What should we do? And we pulled out the SYN packet attack. We said, we just don't know how to stop this attack, so we're not going to announce it. We now think that was a mistake. 2 years later, there were SYN packet attacks, which basically is a low-rate traffic flow that would completely load down a kernel. So you could really make it slow down and stop working. And what happened was that a team of the leading internet experts immediately set up a mailing list, discussed alternatives and algorithms and solutions, and within a week, major manufacturers were deploying solutions based on that list's actions. For me, the denial of service attack, of course, the packets that are coming in had spoofed return addresses, so you didn't know where they came from. And I thought, I wonder if I could trace these packets back, even though the return address is wrong. And the technique I came up with was, I said, we'll find all the possible paths into the target, And then we will go through the links and apply a huge network load to each link and see if we can modulate the incoming packets. Okay? Now, several things came out of this. We wrote a traceback paper. One was the concept of a packet cannon, which is sort of an alarming thought. The second was pain amplification. Can I direct a single packet out that will give more than a single packet's worth of load? The answer was yes. And there were several ways to do that. I, of course, could do this inside Bell Labs, and our tests on the lab network worked fine. And I submitted a paper, and the referees gave two kinds of comments. One, we cannot accept this paper because you haven't tried it on the internet. The other comments were, don't you dare ever try this on the internet. I should tell you that most of those amplification attacks stopped working within about a year, and I'm horrified to learn that they're now back. There are wonderful ways to amplify attacks. NTP has got new services, and there are a bunch of games out there that now offer UDP packets that will amplify. So this stuff is back. This is still, I mean, it's old legacy stuff, but it's still happening. Meanwhile, network mapping. Network mapping, I can map the network by doing a trace route. A trace route traces the outgoing path of a packet. What if I pick 300,000 destinations? I have an outgoing tree that tells me pretty much how to reach all the destinations in the world if I have a pretty good endpoint list, and those are pretty easy. I worked with a fellow named Hal Birch, who was a computer Olympian, and he managed the layout algorithm. What I want to do is, now I've got this big ugly graph, I want to see a picture of it. And Hal managed to make it work. We used brute force and pig ignorance. Let's sort of anneal these points like cooling iron. This was not a new technique, but it turns out at the time the people who did visualizations thought that 700 nodes was a giant graph, and we had 100,000. What we had in our favor was HAL, and the fact that they really hadn't noticed in the last 20 years that computers were a lot faster. An overnight run on a modern Pentium at the time actually gave a pretty good graph. And in fact, there are a couple on the back table back there you can go look at that were published in Wired in 1998 as the first internet maps. I also decided, because I ran these experiments inside Lucent, that anything large enough to be called an intranet is probably out of control. And I will show you some of that in a moment. So the visualization goals was to make a map, make something pretty, show interesting features, debug the database and collection methods. Map needs to be big enough to be hard to fold up. Geography doesn't matter. We're laying out the map in the network's own terms. I'm not trying to put Europe up here and US there, because those maps just have blobs of ink, because there's so much going on. You want to spread it out and you figure it out. And use colors to show meaning. So what we do is we lay out the close stuff first, and here's where some of these slides go. So there's 2 hops away, then 3, 4, 5, 6. You get the idea? We're going through a bunch of slides here until finally we have the whole map. And what does that look like when we do the layout algorithm? This was an early version of it, and it was misbehaving badly. It looks like some mouse running to the lower left. And we keep adding, you'll see little flashes now and then as we add new layers. Because we'd come in the morning and see a beautiful map. And we had no idea that at 2 a.m. it looked like a mouse running down to the corner. But when you added the right layer, see how the algorithm's sort of bringing in the tail? When we're done, the map looks sort of plausible. This was colored by hot iron. The yellow is closest to the scanning host, and black is farthest away. So there you go. That's how the algorithm worked. And you can see it's sort of springy. And what it's doing is simulating physics between each of these, with springs and attractions and stuff, all with made-up physics, but you just keep running around, moving things a little bit, reacting to these forces until it sort of works. And of course, we got slides that looked like this. This was the image that appeared in December 1998 Wired. I wanted it to be a centerfold. They didn't do it. These became extremely popular. By the way, there were lots of interesting things here. This is colored by IP address. You got 4 numbers. We use the first 3 numbers for RG and B, or GRB, or whatever made it look right. So black was AT&T. That was net 12, mostly zeros. This was cable and wireless. There was, that's a military. Over here was AOL. This was France. They had 2 connections into France at the time. Isn't that interesting? That's the sort of stuff you want with a map. You know, there was Netcom and various other companies. We could color by autonomous system number. We could color by IP address. This was a simplified version. The shortest distance to each endpoint. Not quite all the data, but still pretty impressive. Colored by geography. Gray is .net. I actually no longer remember what the colors were, but they're like Europe and so on for different colors. Black is the military. Here was colored by ISP, Internet Service Provider, which is much more useful. Cable and wireless is down here in orange. Here's the internet at night. That joke still sort of works. That's in hot iron. Here is Australia. And here is Yugoslavia. This was 1999. There's a little bit there. There are a couple of things set. Okay, it wasn't a big deal. So most of you will remember that in 1999 we had a little ado with the Yugoslavians. In May we started attacking NATO started attacking Yugoslavia. There was a bad man there in late March, and Steve Bellevin said, "Ches, you should watch Yugoslavia closely." So I went out and found their 600 Class C networks and ran a separate scan each day just to see what happened in Yugoslavia. And it started, Steve and I had the conversation here. These are the number of Yugoslavian routers that were reachable. And you notice on May 5th, something bad happened. And in fact, the newspaper said that NATO had started bombing Serbia. Turns out knocking out the power in Serbia and Croatia. And you can see the long sort of struggle back trying to do this. A general looked at this and said, "Son, you've done remote assessment of bomb damage and we're interested." Another thing we did, Steve Brannigan, a fellow who lives fairly close to here actually. This was the network map to Yugoslavia. Yugoslavia is up here. This is the US. And if I showed you 30 days, you'd see these things blinking in and out. This one was the really interesting piece because it always was connected. And if you go look at the router before it, it was a Bell Atlantic router inside Maryland. The general said, "Son, you found their embassy and we're interested." So by 2000, someone at Bell Labs came around and said, "Do you have any technologies that someone might want to buy?" And I knew that I had talked to a lot of CIOs. I knew corporate networks were out of control. And I had this and another technology. I said, you know, they might pay $50,000 for one of these maps, which is just trace routes. And in September, actually the beginning of October 2000, 7 of us split off a company from Bell Labs called Lometa to try to make a buck on this. And we scanned corporate networks. Here was one where, you know, everyone who runs a corporate network has a list of official addresses in the network. And this showed anything not on the list was red. Oh, well, okay. So now we're debugging the list. And there were some other companies there. This was Lucent's network, by the way. Lucent, you may recall, in the late 1990s, split up, well, actually, in 1996, split up into 3 companies. And I'm not going to show you that here. This was another piece of Lucent with unknown parts. Here were the 3 parts that had to split up: Avaya, Agere, and Lucent. Agere, the folks at Agere didn't like the big company. They're sort of Western Electric. And they pretty much had 3 cables ready to cut. They were easy to separate. Avaya was thoroughly blended in, and it took a long time to get them disconnected from the network. Here was another company. This was a VPN that leaked out. we always found stuff, by the way. Whenever we scanned a company, one of our first customers was free. We said, okay, Microsoft, we'll scan your network if you let us use your name. And this was Microsoft Network in 2000. They did not have these in their list, but of course it was in their backbone. They knew it. It's actually a very clean network with only a couple of pieces in it. Of course, after we did the scan, they said, wait, you can't use our name. We said, we did it for free. You signed this. And of course, as a startup company, you really want to have someone say, well, yeah, Microsoft used us. Here was another company, an oil company. Green was known, this is outside networks. There was a leak. All those packets were running outside, no firewall there. And the network administrator went and looked at that guy and said, it's those guys in Oklahoma. I knew they were screwing up. Okay. Even a small network had an unknown leak. There's also leak detection. Can you find a host that has access to the inside of the corporate network and the outside at the same time? I don't have time to go through the details of this, but basically you send a spoofed address, net packet, from the inside with an outside address and see if it makes it through. Spoofed packet. Spoofing isn't always bad. And you do it the other way too. And you can find machines that will receive a packet and answer out a different interface. So, by the way, these slides are on my webpage, cheswick.com, so you can get details of this. I ran the Internet Mapping Project from about 1998 to 2011. At the end, we were doing 1/3 of a million trace routes every day. I have a giant honkin' database. Nobody has really gone through it much. But we will keep it. I want to give it to the Internet Archive, and they're interested. It's quite a history of the Internet for a while. I left Lometa in 2006. After a while, it's time for the founder to go. The government bought this and reassured me the Republic is a little bit safer. I wasn't clear to know the specifics, but this is okay. I mean, if you know one thing about government networks, they're not necessarily any better run than the outside ones. They just try harder. It still does a number of sales. I did not get a house on Nantucket from starting this company, but it is a nice research result. And being out in industry, actually selling stuff and seeing other business plans gave me a good solid taste of what's reasonable and what isn't. And we're coming along nicely here. I'm up to 79, and these will go fast. So after about 6-month break, I went to AT&T Shannon Lab. Those are the people who had split off from Bell Labs in 1996. And I said, well, I'm done with internet mapping. All the software and stuff is back at Lometa. And within a week there, AT&T said, we need a map, please. Why do we need a map? Well, not for technical reasons, but there's this big ado about net neutrality. And our point as AT&T to the FCC is, it isn't just pipes. These networks are complicated. Your map shows that the network's complicated. That's good enough for us. Please make one for us. So I did. And some of these were put up in the airport at Reagan Airport so that returning congressmen would see them, and so on. So there are other non-technical reasons for it. You will see a lot of talks these days that have the internet maps in them. Some of them are mine, some are by the Opti project, which was started about 5 years after I did this, which basically does trace routes and layouts, the same stuff. While working at Shannon Labs, I also did other visualization. I thought of a new way to see a movie. This is a poster that has every frame of the movie printed on it. And if you look at this, this is not, you can see palette changes, scene changes, and so on. This is an entire 90-minute movie. And if it's a movie you know, it can be very cool to go through and see details because they're high-resolution images and so on. In fact, speaking of Penn and Teller, this particular one was LabScam, which was something they did early on. I still am working on this. I'm trying to find a major producer. This is much more fun if you know the movie. And I'm trying to find some major producer who will let me print out his stuff just to show him. I think you can make money on this. This is Nina Perli, who did a movie called Sita Sings the Blues, which she released to the public domain, so I was free to do this, and she is delighted. So I got a bunch of patents at Shannon Labs, including thumbnails and something called slow movies. I don't have time to show you this now, but it's something that goes about 1 frame every 10 seconds. And it's kind of fun to put on your desktop to look at a couple times a day. I also have done more authentication work. And by the way, these slides will be available, so if you want the images, you can get them straight from there. And I'm still doing stuff. I'm still working on Zoom authentication, which I'm not going to show. Well, maybe I'll show briefly. I'm thinking of better ways to authenticate. Zoom authentication is your password is a place on the earth. And you zoom in. And can you remember the various steps to zoom in to a particular place? And you know, that tree in the upper left-hand corner might be your password. And can you remember this each time? This is an entropometer, and it gives 47 bits of entropy, which is better than any password you folks are using. By the way, you not only can zoom in to a map, you could zoom into the Mandelbrot set. Because the problem with a map is you might pick where your summer vacation was. I don't know anyone who vacations on the Mandelbrot set. This is the first practical use of the Mandelbrot set I've ever seen.
All the passwords are self-similar, though. Mm-hmm. All the passwords are self-similar.
Well, they are self-similar, but if you can navigate in, and of course you can zoom in infinitely, you could go to some place and you could get as much as you wanted, if you could remember the way. And of course the other one is to zoom in on a book. I have 3 books in here, a calculus book. We'll go to page 172 and zoom into maybe this little corner of this square root. And of course you're not having to remember a lot of details, just how you get there. This is the XKD CD Authentication. You pick 2 words out of a list of known words. It's 1024 words. Pick 2 words at random. In this case, example and early, you've got a modest password. And you have to remember example early. You don't get to choose those. On the other hand, no one can figure out that you chose them because the computer did. I'm working on extending this. And I'm skipping over it. You can do sort of Mad Libs sort of stuff. Here is an insult generator I have. You can go to the web and get this. For those who can't read it, you grim-faced pipe of pleuritic snipe sweat. That's a 42-bit passphrase. And a lot of people pick cussing when they access when they give passwords. Oh, yeah. And this is family friendly, I think. Daddy, what's a reliquary? And to finish this up, I'm going to show you, the question is, if you only had to remember one passphrase, and that would lock all the rest of them, like a password wallet, could you remember a password that's strong enough to be cryptographically secure? And the answer is, I don't know. This is, we'll say X. This is a little app that's going to be in the App Store soon. I've run through the crypto stuff. It is a simple password wallet. And what it is, it has picked a random 80-bit password, random number, and encoded it, in this case, from a dictionary of 2 to the 12th words into 7 words. Artery tight reason, excessive advisory, low located. Now, if this was your new master password, you're not going to remember it immediately unless you're exceptional. However, you might copy it and save it someplace and use it every day for a month, and then maybe you'll know it. And the point is, nobody's going to be able to figure out how you figured this out. This actually has a cryptographic work factor of 80 bits. Well, 79. This could be resistant to a government cracking it. In fact, I believe it is, by all my crippy friends who think they know how much the government can do. And you can use different word lists. That doesn't change the security at all. This is the same password with a shorter word list. Shorter word list means more words to remember. That's not especially helpful. Here it is in hexadecimal. Here it is in 32K. Bigger word list gives you bigger words, but fewer of them. Can you imagine having a password where spelling checking is okay? Or we can pick words that make spelling checking or typographical errors easier to fix. Abdomen guidance, Pantheon groundless, Capricorn network. I might be able to remember that after. Remember, once you memorize this, you never have to change it. It sort of becomes your personal mantra. So this is an app that is trying to experiment with this to see if it works. And I've put it up with with what I think is a fairly safe password wallet, and you'll be able to load it for free from the iTunes store in another week or two, and maybe tell me how it works for you. And you can put in other dictionaries. So I'm still working on stuff.
So what's it going to be called?
105, which is the maximum number of bits of randomness I will generate. Okay? I mean, if you decide that maybe the NSA can crack 80 bits, give it 90 bits. It's another word, okay? It's up to you. Where do you do the balancing? Horror vigilance. Let's try this down to the 4K. Atomic furnish blanch. Conductor, false funeral, Eisenhower grass minimal. At the moment, I am working on a pass haiku. Same idea, but it's haiku. Some of these end up being somewhat poetic. And if we can make some sort of haiku that's a little poetic, it might be easier to remember. And I just have to figure out how to encode the bits reproducibly.
But that's going to reduce its...
No. You'll still get 80 bits, man. I'm not changing that. Now, there is a question. See, I have this pick another key button.
But wouldn't the pattern...
The pattern is known to the attacker, but there is still 2 to the 80th bits of randomness in there.
I believe it.
Yeah. It turns out the number of haiku possible in English is a cryptographically useful number. And I have a mathematician friend who counted how many. It's a lot. Much more than Avogadro's number. All right, is there anything else? Okay. So the idea is that there'd be one password to rule them all. You don't have to change it. It's strong enough to last forever. It could be your last password you ever need. And if you leave your cell phone in the hotel room in Beijing and they take it, they probably can't crack it. Which I believe the answer to security is to give everybody mil-spec passwords, mil-spec security. So rounding third here, what's next for me? I'm writing apps. I'm doing some consulting. I'm working with students. There are some startups that I've been doing work with and have a piece. I'm not done yet, but as you can imagine, I'm a bit of a weird bird. When I went to Facebook and said, you guys want to hire me, they basically said, what the hell would we do with you? And of course, the real answer is you hire me and just see what happens. If I can figure out what to do at Bell Labs, I can figure out what to do at Facebook. I have gone to the usual suspects. Fortunately, I have saved my money and I've invested well, and I don't have to have a job. I'm just looking for something interesting to do. You might also ask, well, Mr. Wave of the Future, what are the waves of the future now? Statistics to deal with big data. Go get yourself a master's degree in statistics. You've got a high-paying job for many decades. Genomics, molecular biology, all that stuff going on with DNA and epigenetics and RNA. You don't have to kill any mice to do this. There's a lot of computing involved. There's 100 years worth of work to do. You can cure diseases. You can stop aging. Please get on that. You can get a Nobel if you do it right. And don't forget plants. You know, there was a Nobel Peace Prize given to Norman Borlaug, who was credited with saving 1 billion lives, and he did it by messing with wheat. There are more of those Nobels available. Just go get them. And that is my talk. I've got a minute left for questions. Thank you for your attention.